Hello everyone, Greg here. Welcome to our week 6-7 transition video. It was an awesome day in Oregon today. Got a really good bike ride in, perfect weather, and boy, my mom's a little bummed. The Predators are done, and I know Evelyn's probably sad too. But my mom and I, hockey's over. I check out for baseball, but then I check back in for football. But she'll be all right. I know it's kind of sad. Anyway, so we're moving on into week 7. Now, I really appreciate your flexibility in this week. If there's one thing that is critically important that you leave this course with, it's that you know how to do and what the following are for. A one-sample t-test and what type of hypothesis it goes with. So if you assume that a certain value in a population is 20, a one-sample t-test will tell you whether you can reject that or not. And we've discussed the two independent sample t-tests. That's for comparing two different groups, the scores of 8th graders in Kansas and the scores of 8th graders in Nebraska. And from a sample, you determine whether you can reject the null hypothesis that the means are equal. And that always happens if your p-value is low, the p-value being the probability of making a type 1 error. You're now familiar with what a two-dependent samples test does, and that assignment doesn't make that clear. That's a before and after test. The same 10 people take a pre-test, and then the same 10 people take a post-test. Whether it be a math test, a spelling test, a safety test, any kind of test, to see if there's a statistically significant difference. So you'd be determining whether if the whole population took this test and then the whole population took the test 3 days later, would the means be different? Your ANOVA is the equivalent of a two independent samples t-test, but it's for 3 independent samples. So your null hypothesis in an ANOVA is that the mean of population 1 equals the mean of population 2 equals the mean of population 3. And if that is not the case, then the alternative hypothesis is that at least one of the means is different. So there's also something called a repeated measures ANOVA, which is just like a dependent samples t-test. It would mean if you took one group and measured it 3 times. We don't go into that in the course because that doesn't happen too often. And next week we'll talk about our last test, which is correlation and regression. Now, if you are going to be successful in quantitative research, and I know you are, and I hope you choose to lean your dissertation that way, these 5 statistical tests are basically all that are used unless you get into a real complex design. So go away from the course knowing how these 5 are used well, and you're going to use them in your final project, and things are just working pretty well. Okay, the last thing, our correlation and regression assignment will be Thursday, and I will send that out to you, and it'll take an hour or so, but it'll be very crystal clear, and it'll help you understand correlation. Now, the other thing you have to realize is when you use SBS tests to generate statistics, t-values, f-values, p-values, you don't copy and paste SPSS into the final project or a dissertation. You simply use it to get the data. Then you create your own table. And so whenever you're done with a statistical test, you're going to have what I call a write-up, which is that something to the effect of the null hypothesis, which is that the mean test scores in Kansas and Nebraska are equal, can be rejected because the p-value is less than or equal to 0.05. And then you always have to put an APA statement in your verbiage, and it would look like this. For a t-test, it's always the t-value, the degrees of freedom, the actual test stat, it's called the test statistic, and then the p-value. Now the p-value is called significance in SPSS. It means the same thing. For ANOVA, we use an f-value and 2 degrees of freedom. And then it's the same. Now it's important to understand The degrees of freedom in a dependent samples t-test is the number of samples minus 1. The degrees of freedom in an independent samples t-test is the number of samples minus 1. And in a 2-sample independent test, it is the sum of the 2 samples minus 2. And in ANOVA, there are 2 degrees of freedom. There are the number of groups minus 1, and then there are the total number of samples minus 2. I might have that mixed up, but it's very easy to figure out how to compute the degrees of freedom. Now, what you have to do is use that sheet that I sent out that shows exactly how to state in APA language the results of a statistical test. And that has to be there so that another person reading that paper can go, oh, you had 2 samples. Here are the samples. And here's the mean and standard deviation of each sample. Now, I will run a 2 independent sample t-test on these samples and see if the author, you, came to the same conclusion. That's why there's a standard way of formatting that in APA, because people do that. And I found 2 sample t-tests in dissertations and papers that had the wrong p-value. That's why it's transparency. It's open for others to look at your data and run the test and verify them. Okay, so I'll get you that degrees of freedom on the F-test in a minute, and there's always 2 of them. Now, so moving on to next week. The goal next week is to understand correlation and regression. Now, correlation, give you a quick example here. Here's our correlation of hours studied and scores on some assessment. And it's pretty easy. I will send you how to put the correlation into SPSS. But what you'll generate is an R value. See if I got that here. Yeah, an R value, which is the Pearson correlation coefficient. And you report that in APA format also. And I'll be sending you a study that's a perfect correlation study. The other thing is, a correlation can be significant or not. If you have a very tight correlation, you feed your kid 1, 2, 3, 4 carrots per day, and he scores 50, 60, 70, 80, 90 on the math test. That's a perfect 1 correlation, but it's not statistically significant because the sample's too small. So once again, you have a hypothesis test for correlation, and your null hypothesis for correlation always is that there is no correlation between 2 variables in the population. Then from your sample, you reject the null hypothesis that there's no correlation in favor of the alternative that there is. Now, one thing to remember is there's no such thing as a directional correlation. Something either correlates or it does not. It can't be a greater or lesser correlation. Whether a correlation is positive or negative is not directional. And so that's pretty important. So I'm going to have more on that in the morning when I send out Thursday's assignment. So 1 assignment Thursday, then a journal entry Saturday. Now the next thing is we need to start thinking about the final projects, and I found that if people that wait till the Monday of that week 8, it's hard to be successful on either of those final projects. So I'd like to, by Saturday, have you sharing them with me in a Google Doc, and then we can have a phone conversation and see if you're either in the ballpark. Because generally what happens is people aren't really even in the ballpark right away. And once you see a model and see how it gets laid out, you'll feel much better. So it takes about several days to set it up, and then you have all of week 8 to get it fine-tuned. So I want to do that with you, and so we can have some superb final projects. So I really appreciate everybody's flexibility. This is hard concepts, but I guarantee you when you leave the course, you'll have this and you'll take it with you into your dissertation, and it'll be a good thing. So, well, it's coming up on 10 minutes. We've got to wrap it up. So have just a wonderful week, and to all you Predators fans out there, Evelyn, next year. Okay, have a good evening, everyone.